Hello, everyone. It's an honor for me to speak at such an important analytical event. And I work at Yandex Money, which is the biggest Russian payment online solution. It's based in Moscow and St. Petersburg. And it provides payment solutions for more than 75,000 merchants. And we have more than a million active clients. And what I'm going to talk about is this task. How we used RapidMiner for the task of classifying high-risk merchant websites. Here is the problem. The key thing about the problem is brand damaging. This means that there are regulations coming from payment systems like Visa and MasterCard, and they prohibit certain types of things to be sold at all. And also they have some high-risk categories which are allowed, but they require a lot of limitations. So you can't sell drugs, weapons, or porn for credit cards at all. But you can have an adult shop, you can probably sell brand replicas, but this is under the limitations. So what we have to comply with, these are quite well-known programs from both MasterCard and Visa, and these programs are aimed to protect their respective brands. So here is the task as it was initially issued by the business. We have to automatically scan websites of internet shops of the merchants and to find ones which do not comply with the regulations or prohibitions and manually screen them thereafter. And as I've said, we have more than 70,000 merchants, and the first round we had to classify 15,000 websites. These are key concerns which were important before we started with the task. First of all, the speed of website scanning actually doesn't matter. Because we want to accurately classify websites, and it doesn't matter how fast we do it. There are many of websites, so we want to automate everything, like download, process text from websites, and then classify. We have to carefully pick the training data set, which involves like searching the web for drugs and weapons and porn. It's quite quite funny. And there are some uncertain categories, like you can distinguish whether the website sells weapons or it doesn't. But some categories, like replicas or magic-related stuff, they are quite uncertain. And also we want to set a threshold for the classification, because if the site just a bit looks like this or that category, like we don't want to manually look at the site. We must set quite a high threshold for the classification. Surprisingly, it's RapidMiner, which I used. These are the main steps of the process to obtain, to form the test and training data set. I decided to use text mining extension within RapidMiner, then build the classification model, then download all websites we have to classify, and then apply model to them. So this is how the training process was organized. In the training dataset, we had 11 categories. I'll show them to you later. And it consisted of 269 labeled sites, which resulted in 28,000 unique words. Then we do some text processing, like we had to extract text information from every website to tokenize stem, find unique words within it, and then build the TF-IDF matrix. I'll talk about it later. And then the model was chosen, the very simple one. It's k-nearest neighbors with a cross-validation. A bit about TF-IDF metric. Basically, this is a metric which shows importance of every unique word relative to the document. Like if you have some word appearing often in one document, but it doesn't appear in any other document, then it is important for that particular document. If the word is seen throughout all the documents, it is not considered important in the classification. Here are some RapidMiner insights. What I did as an input, we have a labeled list of websites to train the model. Then we loop through every URL and download it using an external call of wget. Then we process the text and build the TF-IDF matrix, and then we have a k-nearest neighbors cross-validation with leave one out option for better accuracy. Here is just one example of not the best confusion matrix. And this is a highlighted column and highlighted row. So the categories are on the left, like adult stuff, drugs, replicas, weapons, etc. And there is also a category called normal guys, which means this is a good site and it doesn't sell anything prohibited or suspicious. So what are the highlighted rows and columns? The highlighted row at the normal guys category means that we misclassified this site. We said these are normal guys, while actually they were selling drugs or replicas or something else. So this is the classification error. And the highlighted column means that we classified normal site as being suspicious. So this is the additional work for us to manually screen and classify the sites. Then I built a test process just to try to do everything at once. So here we have a list of sites as the input. We have text processing, some data management, and then applying a model to them. And this process took about 1 hour to download and classify about 900 websites. But here we come to the limitations of the process, because the data sizes are quite big. Sometimes they won't fit into memory. So one site makes about half a megabyte up to 1 megabyte of text. And the corpus, which is a set of websites, may take up to 300 megabytes. And here are the sizes of the metrics we have to work with. Like the training data and test data, you see it's quite big in terms of the volume and in terms of number of attributes. Like words here, mean unique attributes in the data set, so the matrices are quite big. Okay, so to deal with memory problems, I used batching approach, which means we have thousands of websites to classify. We have to download them all, but I decided to download them in batches, place them in separate directories, and then loop through all directories. So the classifier runs once through every batch of sites. And every batch is about 200 or 300 websites. So it made 15,000 sites, made 50 batches of 300 files. So we basically loop through every URL, place them in a separate directory, and then loop these directories to run the classifier through. So the k-nearest neighbors, for those of you who may have forgotten about it, here is a sample illustration of how it works. Basically, it provides a measure of similarity of a known example to known examples. So it is really simple, the simplest model you can think of. And second, it's quite interpretable. So when business people look at this, look at the results, it's obvious for them that this site is very much like selling adult stuff. So it's easy to interpret. I chose the parameter car equals to 5 because we want to have a confidence parameter for the classification, and k equals 5 gives us a nice confidence level. Here is another matrix. Like the highlighted sites are the ones which are interested in, because they are not in the normal category, and the confidence for the prediction is higher than 80%. Like, we don't want to look at the normal guys, even there's any confidence at all, and we don't want to look at the sites which has equal confidence through a few number of categories. We consider them normal also. Okay, so what's in and out? We have a very big list of websites. We have RapidMiner process, and here is the result which I present to business people. Like, these sites are predicted to be these high-risk categories with this given confidence, and they require manual check afterwards. And a few words about performance and accuracy. I tested the classifier on the randomly picked 100 websites. So it took 7 minutes for one part of RapidMiner process to download them all, and it took only 30 seconds to process all the text from the websites, like tokenizing, stemming, the standard one. So it's about 0.3 seconds per one site to classify. And I had about 89% accuracy obtained at the cross-validation process. I had one false negative, which is a high-risk site which was classified as normal. But from the other hand, the model classified correctly 12 out of 13 high-risk sites. And also it had 0 false positives. So quite a good result. Okay, and to finalize, what's next? Because there's plenty of work to do more on this system. We can deploy it on the server, which I haven't done yet, and automate the whole process. And I have plans to further improve the accuracy of the classifier by using not only single unique words, but B and 3 grams to incrementally update model with new data. And we may automate scanning the website, which means we don't need to input the big list of websites to scan. We may take just referral domains from payment system information and automatically parse the domain names from this information. So practically, it could be fully automated and sending reports once in a while. So that's it. Thank you.